Oh, Present, good evening. This is Dr. Ambek Raja, PhD founder Computer Science. I'm taking subjects Advanced Data Structure and Algorithm, Unit 5. Backtracking is an algorithmic technique where the goal is to get all the solutions to a problem using the brute force approach. It consists of building a set of all the solutions incrementally. Since a problem would have constraints, the solution that failed to satisfy them will be removed. Backtracking makes it possible to solve at least some large instance of the difficult combinatorial problem. General method. Backtracking is an algorithmic technique whose goal is to use brute force to find all the solutions to a problem. Because a problem will have constraint solutions that do not meet them will be removed. Explicit constraints, implicit constraints. Explicit constraints are the rules that restrict each xi to take only values from a given set. For the example, xi is greater than or equal to 0 or si, all non-negative real numbers. Implicit constraints. The implicit constraints are rules that determine which of the tuples of the solution space satisfy the criterion function. The implicit constraints describe way which the xi must rules. Backtracking algorithm applications, n-queen problem, sum of subsets of problem, graph coloring, Hamiltonian cycle. N-queen problem. It is a classic combinatorial problem. The 8 queens puzzles, the problem of placing 8 queen puzzle is a problem of placing 8 queens on 8 into 8 chessboard so that no two queens attack each other. The result that no two of them are the same row, column, or diagonal. The 8 queen puzzle is an example of the more general 8 queen problem placing n queens n into n chessboard. The algorithm starts by placing a queen in the first column, then it proceeds to the next column, and it places a queen is the first safe row of that column. If the algorithm reaches the eighth column and all the queens are placed in a safe position, it prints the board and returns true. A classical combinatorial problem is to place 8 queens on 8 into 8 chessboard so that no two coins are to the same row and column or diagonal. We will solve 8 queen problem by using smaller procedure adapted for 4 queens problems. The algorithm of 8 queens problem can be obtained by placing n equal to 8 in n queen problem. If two queens are placed at positions ij and kl, there are the same diagonal only. Some of the subset of algorithm. Some of the subset of some problem is the problem of finding subset that sum of elements equal a given number. Backtracking approach generates all permutations in the worst case, but in the general, it performs better than the regressive approach toward the subset of some problem. Subset of A of n positive integers, a value sum of D is given. Find whether or not there exists a subset of given set, the sum of whose element is equal to the given values of the sum. Include the current element subset of recurrence remaining sum. Exclude the current elements from the subset of regular remaining elements. For the steps yes, we are following the start with an empty set or the next element from the list to set. If the subset is having some m, then the stop with the subset of a solution. If the subset is not feasible or if we have reached to end of the subset until we find the most suitable value. If the subset is feasible, sum of subset D, then go to step 2. If you have visited all the elements without finding a suitable subset, and if no backtracking is possible, then the stop without solution. So for example, yes, 3, 5, 6, 7 and D equal to 15. Find the sum of subsets using a backtrack 3, 5, 7. Graph coloring refers to the problem of coloring vertices of a graph in such a way that no two adjacent vertices have the same color. This is also called the vertex coloring problem. If coloring is done using most M colors, it is called M coloring. Applications of graph coloring, design a timetable, Sudoku, register allocation the compiler, map coloring, mobile radio frequency etc. Hamiltonian cycle or Hamiltonian circuit is a cycle that visits each vertex exactly once. A Hamiltonian path that starts and ends with the adjacent vertices can be completed by adding one or more edges to form a Hamiltonian cycle. and removing any edge from a Hamiltonian cycle produces a Hamiltonian path. Let G equal to where V comma E should be connected graph with n vertices. Hamiltonian cycle is a round trip path along n edges of G that visits every vertex once returned to the starting position. It is also called the Hamiltonian circuit. Hamiltonian circuit is a graph cycle through a graph that visits each node exactly once. A graph possessing a Hamiltonian cycle is said to be a Hamiltonian graph. Hamiltonian cycle using backtracking algorithm create an empty path array and add vertex 0, add other vertices starting from the vertex 1. Before adding a vertex, check whether there is adjacent previously added vertices are not already added. For example, this graph, branch and bound, branch and bound, branch and bound, or branch and bound is method for solving optimization problem by breaking them down into smaller subproblems and using the bounding function to eliminate subproblems that cannot contain optimal solutions. Branch and bound is another method to systematically search a solution space. Just like backtracking, we will use bounding functions to avoid generating subtrees. Branch and bound differs from backtracking in two important points. It has a branching function, which can be a depth first search, breadth first search, or based on the bounding. It has bounding functions which goes beyond the feasibility studies. Branch and bound refers to all state space search method in which all children of the E node are generated before any other live node becomes a E node. Live node is a node that has been generated but whose children have not yet been generated. E node, that's edge node, is a live node whose children are currently being explored. In other words, E node is a node currently being expanded. Dead node is a generated node that is not to be expanded or explored any further. All children of a dead node have already been expanded. Branch and bound refers to all state space search methods in which all children of E node are generated before any other live node can become E node. Branch and bound applications is algorithm is an excellent addition to organization problem solving armory. Discrete optimization, combinatorial optimization. Traveling salesman problem is an algorithmic problem tasked with finding the shortest route between a set of points and location that must be visited. In the problem statement, the points or cities in the salesperson might visit. If you look at the graph below, considering the salesman starts from the vertex A, they need to travel through all the remaining vertices B, C, D, E, F, and get back to A while making sure that the cost is taking minimum. There are various approaches to find the solution to traveling salesman problem: naive approach, greedy approach, dynamic programming approach. In this, we're learning about the traveling salesman problem using greedy approach. LC branch and bound is heuristic cost function to compute the bounded values. Nodes are added to the list of live nodes as soon as they get generated. Let's assume that the cost of node 2, 3, 4, and 5 are 25, 12, 19, and 30 respectively. Since it is the least cost branch n bound, so we'll explore the node. Assume the cost of node 2, 3, 4, and 5 are 12, 16, 10, and 315 respectively. In this method, we will explore the node which is having the least cost. During exploring node 4, which is element C, you can notice that there is only possible element that remains unexplored, which is D. NP class, that is a non-polynomial. NP class stands for non-deterministic polynomial time. It is a collection of decision problems that can be solved by a non-deterministic machine in polynomial. Hard and NP, a problem is NP hard if an algorithm for solving it can be translated into one for solving NP problem. NP hard therefore means at least as hard as many NP problems, although it might in fact harder. NP complete problem that can be solved in polynomial time if and only NP complete problem can also be solved in polynomial time. NP hard can solve a polynomial time, then all the NP complete problem can be solved in the polynomial time. Complete problems is circuit satisfactory problem, set cover, vertex cover, traveling salesman problem. NP complete problem determining whether a graph has a Hamiltonian cycle, determining whether a Boolean formula is satisfactory. Thank you.